Hi folks, and welcome back to Math with Captain Rod. Making this video here to hopefully finish up our notes here on functions. So what we're looking at here, we've got a couple of functions here. F of x equals x squared minus 9, g of x equals 2x plus 6. And we're going to try to calculate this thing here, f plus g of 5. You'll notice I said of 5 and not times 5, because in function notation, even though this might look like a multiplication, in function notation it's not. Let's start with this. All right, f plus g. I'm going to do this off to the side here. So, f of x plus g of x, right, is literally just the sum of these two things. That's going to equal x squared plus 9. I'm sorry, not plus 9. Minus 9 plus g of x, which is 2x plus 6. And we can simplify this a little bit. Let's see, x squared we'll just leave alone. The 2x will leave alone, and the minus 9 plus 6, that's minus 3. So here is our function here. We can call this some new function, like h of x, which is equal to the sum of these two, f of x plus g of x. So really what we're looking at here is we're looking for h of 5. And this would be the notation for h of 5, just like f of x means, take x, put it into this. H of 5 means take 5 and put it into this function. So that's going to equal 5 squared plus 2 times 5 minus 3, which is, what, 25 plus 10 minus 3. Let's see, 35 minus 3, 32. We get a numerical value out of that. All right, next one here. So this one reads f times g of minus 1. So let's start by finding f times g, and I'm going to call that a new function, h, which is equal to f, x squared minus 9, times g, 2x plus 6. There's my new function. Now we could distribute this if we want, but there's really no reason to. What we're interested in doing here is evaluating that function when x is equal to minus 1. So we're looking for h of minus 1. That's going to be minus 1 squared minus 9 times 2 times minus 1 plus 6. A lot of parentheses there. I want to be very careful with these things. So we can simplify this sum. Let's see, negative 1 squared is 1 minus 9. Right? That's a negative 8, I believe. 2 times minus 1 is negative 2, plus 6 is 4. The product, minus 32. All right. Let's take a look at this guy. F over g of 4. So first we're going to start by figuring out what this is. F over g. And I'm going to give that a name. We'll call that a new function h, which is f over g. Just want to make sure I get the right ones in the right place. Let's see, f was x squared minus 9. Okay. Oh, sorry about this. So we're looking at x squared minus 9 over g, and I forgot what g was already. 2x plus 6, I believe. Yep, 2x plus 6. So there's my new function h. Now we're trying to find that function evaluated at 4. So what this means is h of 4. And we'll just run 4 through this function here. So that's going to be 4 squared minus 9 over 2 times 4 plus 6. Again, that was a plus 6. So let's see, 16 minus 9, I think that's 7. 7 up top, and 2 times 4 is 8, plus 6. Was that 14? This can be simplified. All right, further down here. Composition of functions. So now what we're doing is we're going to be putting, well, let me back up. What this reads is f of g of x. And what that means is we're going to take g of x, and it goes into the function called f. So the function g was 2x plus 6, and f is equal to x squared minus 9. So here's what that's going to look like. Here's the function f of x. where this would be an x. But in place of that, what we're going to do is put g, 2x plus 6. So what we're looking at here is f of g of x. And you'll notice what I've done is taken g of x and put it into f of x. Remember, x squared minus 9 was f of x. We could expand and simplify, but I'm not going to bother. I'm just going to move on. Next one here, g of f of x. So what this means is we're going to take f of x, and it's going to go in place of x in the function g. So this was f of x. This is g of x. So what we're going to be doing is placing this function into this one. So that's going to be 2x plus 6, the quantity squared, minus 9. And again, these are called the composition of functions. More examples. All right, let's see what we're looking at here. F of g of x. So this means we're going to take g of x and it goes into f. So that's this function is going to be placed here and here. So that's going to equal 2x plus 1 squared minus 3 times 2x plus 1. This could be simplified, but I'm not going to bother. Okay, g of f of x. Now we're going to take f of x and it goes into g. So that means this is going to go here. So this is going to equal 2 times x squared minus 3x plus 1. Again, that's what you get when we take this function and sub it right there into x, or 4x into this function called g. This can be distributed and simplified, but I'm not going to bother. All right, the next group of fun here. So we've got this function f of x equal to minus x cubed minus 7, and a function g equal to x plus 1. And let's see, what are we looking at? F of g of x. This means take g, put it into f. That means this function is going to go here, or in for x here. So this is going to equal minus x plus 1 cubed minus 7. And again, this can be distributed and messed with, but I'm not going to bother. I think I had meant that to be an equal sign. And again, minus, and then x plus 1 cubed minus 7. Yep, we're good. All right, this animal. Here we're going to take f of x, and it goes into g of x. So that means we're going to take this, and it goes in for x. So that's going to equal minus x cubed minus 7 plus 1. Right? Again, that's what you get when you take this, sub it right here for x, and then you've got that plus 1 left over. All right. Evaluate a composite function. So this is the same thing we were just doing, except now we're going to actually put a numerical value in. Now there's a couple ways to do this. One, we could find f of g of x and then run 3 through it. Or we could find g of 3 and run that in through for x. And let me do that. Let's start by finding out this, g of 3. So g of 3, and I look to my function for g, that's equal to 2 times 3 minus 7, which is negative 1. So that means this thing is equal to f of minus 1, which is minus 1 squared plus 4, and we get 1 plus 4, which is 5. So that's one way to handle that. I think that's probably the simplest. Other way to handle it is to take this function, sub it into here. Right? F of g of x would equal 2x minus 7 squared plus 4. And I get that by just taking this and subbing in for x here. And then we could just do f of g of 3 would mean now just place a 3 in here. 2 times 3 minus 7, the quantity squared, plus 4. I'm going to leave that as an exercise to the reader to show that that's equal to 5. All right, number 2. Let's start by finding f of 3. And we can do that by subbing 3 into our function here, f. That's going to be 3 squared plus 4. 9 plus 4, that's 13. And now what we want to do is to take 13. That's going to be here now, and this reads g of 13. So we look to our function g, 2 times 13 minus 7. That's 26 minus 7, 19, I believe. Very last one here. Let's see. F of g of x. That makes that means take this in for x here. And I've already done that, but I'll go ahead and do it one more time. So again, f of g of x means we're going to take g of x, which is equal to this, and it goes in for x into the function f. So that's going to be 2x minus 7 squared plus 4. This can be simplified, but I don't see any need. Okay, one more. Well, maybe a couple more. Nope, just one more. All right. G of f of x. So this means take f and it goes into g. So our function f was, I guess I got to go back and take a look again. X squared plus 4, and that's going to go into g, which is 2x minus 7. So it's going to be x squared plus 4. I think that was 2x minus 7. I don't have these sitting in front of me anymore. Double check that. This into this function, 2 times x squared plus 4, and then minus 7. Two times x squared plus 4 minus 7. All right, we're good. Evaluating regression lines. So I'm going to stop this video here because that's another topic, and I've already got other videos on regression anyway. One thing I want to do before I end this video here, because I think this thing said something about domains and ranges. I'm going to go back and just kind of chat about that across all these, or at least a lot of these that we went through. So for algebraic functions, I always say this. The domain is always start by thinking, probably all real numbers, unless you can eliminate things. So what you're looking for to eliminate values of x are division by zeros or square root of negative numbers. And by the way, not just square roots, fourth roots, sixth roots, any even roots. You cannot take an even root of a negative number. If you don't see either of these, the domain will default to all real numbers. So as we look through this, right, the domain of this function, right, there's no division by zeros and no radicals, so all real numbers. This one, all real numbers. All real numbers, all real numbers, all real numbers, all real numbers. And again, I'll make other videos that demonstrate examples of where there are domain restrictions. So anyway, just want to do a quick little review about that. This video is getting a little on the long side. I hope that this helps. Have a great day.